water. So these are actually called waves, and we can say that the energy is being transferred from one surface or from one medium to another, and by a process called vibration. Okay, so basically there are two type of waves. One is the transfer waves and the other one is the longitudinal wave. Okay, so as you can see, the transfer wave is in the first picture and the longitudinal wave is in the second picture. Transfer waves and transfer wave hand actually move up and down repeatedly, and that's why the transfer waves are produced. Whereas in longitudinal waves, hand move backward and forward along with the medium. So this is why the compression is actually occurring in the string and causing the longitudinal waves. Okay students, now let's have a deep look at the transfer waves. That what are actually transfer waves? Transfer waves basically are the waves which travel in a direction which is perpendicular to the direction of the vibration. For example, as you can see a sort of graph which I have represented on your screens, you can see, so the direction of the vibration and the direction of the wave, basically when they are perpendicular to each other, it means that they are producing the transfer waves. Okay, so let's have a look at the generating of the transfer wave. For example, the transfer wave, for the transfer wave, there are the hands are present on the both sides, and from left to right, basically, the man is moving his hands up and down. Due to that, the section of some ropes are actually moving up and down, and the other hand, the right hand is still. But when it's moving the rope or the string, so what's actually happening? The string is actually moving up and down. Due to that, the waves are generating, and such type of waves are basically called the transfer waves. Okay, so now let's have a look at the transfer waves. We have some examples here of transfer wave. For example, the water wave, rope wave, and light wave, and electromagnetic waves. All these all are the example of transfer waves. Okay, now come toward the longitudinal wave. Basically, it is the second type of the wave, and these are the waves which travel in a direction parallel to the direction of the vibration. Basically, they are not perpendicular to each other. When the direction of the vibration and the direction of the wave are in parallel direction, it means that they actually produces the longitudinal wave. Here you guys can see that how the longitudinal waves are generating through a spring. For example, we are not taking string or we are not taking a rope here, but we are taking a spring, and because in a spring there are side to side movement, and when the spring is actually moved, so such type of wave which are actually produced by the moving of a spring, so these waves are basically from side to side, and these are called longitudinal waves. Okay, now moving toward the characteristics of a wave. Basically, there are certain characteristics of a wave which we have to go through. For example, the wave has crest, it has trough, it has amplitude, it has wavelength, frequency, period, and speed. Let's start with the characteristic, the first characteristic, which is the crest and trough. So crest basically are the higher point of the wave, as you can see in the graph which I have drawn, and the trough are basically the lower point of a wave. Moving toward the next characteristic, which is the amplitude, basically it is the height of the crust and the depth of a trough measured from the normal undisturbed positions. Okay, so basically this is the height of a crust or the depth of the trough, which is measured from the normal undisturbed positions. Okay, so what would be the SI unit which we can consider for amplitude? Basically, its unit would be meters, because it's a distance definitely, so its unit would be meters. The next characteristic of the wave is the wavelength. Basically, wavelength is the distance between the two successive crest and trough. And what is the unit for the wavelength? Basically, because it is the distance, the wave also has some distance. It has also some, so that's why we actually measure it in the meters. So the SI unit would be meters. Let's move toward frequency. Frequency basically it is denoted by small f, and it is the number of the vibration in 1 second or the number of oscillation in 1 second. Basically, it is called frequency. Now, what would be the unit for frequency? Basically, there was a scientist whose name was Hertz. So he gave, and he actually discovered the frequency. So he gave the name, or he gave actually the unit of frequency on his own name, and the unit is now called as hertz, and it is represented by hz, capital H and a small z. And 1 hertz is actually the one vibration in 1 second, and 50, it means that 50 hertz would be the 50 vibration in 1 second, and so on. Okay, so the next characteristic of wave is period. Basically, it is denoted by t, or we can also call it the time taken. Basically, it is the time taken for the complete vibration, for one complete vibration, or one complete oscillation, or one complete cycle. As we are dealing with the time, definitely the time or the period, the SI unit would be second. So the SI unit for the period is also second. Okay, so now let's move toward the relationship between the time period and the frequency. Basically, both are actually inversely proportional to each other. For example, the time, when the time period increases, so the frequency decreases, and when the frequency increases, the time period decreases. So basically, they have an inversely proportional relationship between them. Okay, so the next one is the speed, and basically the actually when the wave actually moves, so it moves with certain velocity, with certain speed, and it is also measured in meter per second. This is very important, basically wave equation, and basically it actually tells about the speed of the wave, that the speed of the wave would be what would the speed of the wave. Basically, we can determine the speed of the wave by multiplying the lambda and the frequency. The lambda basically is the symbol which we can use to denote the wavelength, and the small f basically we use for frequency. So v equals to f lambda, it is the equation which we can use as the wave equation. Basically, this equation is also called the wave equation, and we can use this equation whenever we would have to figure out or find out the speed of the wave.